Hey everyone, it's Wilmer from the Game Academy. In this episode, let's add an external force to our particle effect and control where it moves. Almost like magic. Here's what we're starting with. Some purple flames, organic looking and mesmerizing like a lava lamp, but pretty much useless. Okay, maybe not useless, but uncontrollable is a better word. To remedy that, we'll use a few extra nodes and another component that we haven't seen before called a VFX Parameter Binder. When we're all done, we'll have a little null object that can steer all of the flaming tendrils coming off the particle system and direct them toward a 3D point in space of our choosing, and thus we'll have a new level of interactivity with our graph. If you haven't checked out the earlier videos in this series, definitely look for the links to those down in the description. Or you're also free to start here if you already know the basics of the VFX graph. Just get the correct version of the starter project from GitHub. Again, the link is in the resources. The main thing that we're going to add to our system is an extra force block to the update context. So at the bottom of update, let's right click and add a block, or use the spacebar hotkey, whatever you prefer. Select a force block and we'll choose our basic force. This starts with a default value of 100 in the absolute mode. You'll need to compile and or refresh the graph. Now we won't see a whole lot of differences if we go back to the editor, but there is a small force now pushing the particles in the positive world X direction. It's a little hard to see until I turn up the magnitude of the force. Now, by the time I get to about 20 or 25, the particles look like they're streaming toward the positive x-axis really vigorously. If I use something a little bit lower, we'll still see the smoke curls that we get from the vector field and the turbulence, but we also have that attractive force pulling the particles on top. So remember, we have two forces already at work here. The blocks are just being applied in order. What we want to do is determine a specific point in space where we will attract our particles. Let's call that our attractive target position. At a given moment in time, our system might look like this with lots and lots of particles. If you have the current position of an individual particle, you can determine the direction to our target position using some simple vector math. Subtract the coordinate of the particle from the coordinate of the target, and you get this vector that represents the difference. Essentially, that's a direction. Input that direction into the force block, and we can push or pull, depending on your point of view, our particles toward a single 3D point. To implement this, let's first convert our force block from absolute mode to relative. That gives us a vector 3 as input, which is what we want, since we'll be supplying a directional vector. And create a vector 3 parameter on the blackboard. Click plus, vector 3. Rename this to attractive target position. I'll expose it in the inspector. Default it to 000, and let's give it a tooltip. Tell the user to use VFX Parameter Binder to attach to target GameObject. Don't worry, I'll explain what that means shortly. Drag this parameter into the work area. I want to get the difference between this 3D position in space to a given particle's position. To do that, I'll need to change the coordinate system to the local space of the particle. We can do this pretty easily with a change space node. Operator math, geometry, change space. Hook this up, and that will convert the attractive target position to the local space of an individual particle. As far as getting the particle position itself, we can use another node to do that. Operator attribute, and I want get attribute position. And sorry, there are lots of menu items in here, so let me filter and find it. Now that we have a pair of 3D positions, we need to take their difference with a subtract node, and that's under math, arithmetic, subtract. That creates a vector direction from the particle to the target. These vectors will all be different sizes if you only do a subtract. We don't want the particles to have different speeds, so we'll add another node to normalize each vector. And I'll just filter for that, normalize. This will turn each directional vector into a unit vector with a magnitude of 1. Let's add a general strength multiplier on top of that before we connect it back into the force velocity input. In the blackboard, add a float parameter. Click plus, float. and let's call it attractive strength or something to that effect. Expose it in the inspector, and I'll give it a default value of something between 10 and 15. And this tooltip will say attractive force multiplier. Drop this into the work area and connect this to our normalized vector with a multiply node. And then we can connect that into our force block. In the inspector, double check that your flare VFX is untransformed. We didn't account for that in our graph, so better to keep that with 0 translations and rotations. If you want to reframe the effect, it's a little bit easier to move the camera, and I'll shift mine so that it's more in frame. We've exposed a vector3 parameter called attractive target position, but that's still at 0, 0, 0 and doesn't relate to anything in the scene. We want to connect this parameter with a real transform that we can move around. Create a null object called VFX Attractive Target, right-click, create empty, and this is just a regular game object, but we'll use it to contain a transform position. We can create a special connection between a parameter and something in the scene using a special component called a binder. In this case, we want to bind a parameter with a transform's vector3 position. Select the VFX flare object and add component. Filter for VFX binder. And you'll see that we have a number of binders in here. The one that we want is called VFX Parameter Binder. Click the plus icon and add transform position to the parameter bindings. Select that and let's open up the details. Hit this caret-like icon to the right of the top field, and we want to select a specific vector3 parameter from here. We only have one option, and that's attractive target position. And then in the target field, we want to select a transform to attach this parameter to, and we'll just browse for the VFX Attractive Target. That will connect the game object with the parameter. And now that those two are linked, we can do some semi-cool stuff. Drag the VFX Attractive Target around and look how the stream of particles follows it around. So let's shove that side to side or up and down, and look how the particles respond. Feel free to add an icon to your target object. Now this only shows up in the scene view, of course. You might want to attach a small cube or sphere under the VFX Attractive Target if you wanted to visualize it in the game view. I'll just scale it down a little bit, and then that will help you see how the flames crawl toward the target position. Use the attractive strength parameter to dial the intensity of the force up or down. Now with the lower values, you can see more of the curls of smoke. Remember that we have the turbulence and the vector field force already working. The extra attractive force that we've added is combined with those. Now you can even make the strength value negative, and that makes the force repel particles from the target. That can make for some interesting or odd results depending on where you place the target, so just use that at your discretion. If you want to allow the user to control the force of drag or air resistance, you could add a parameter to the blackboard. And let me just do that really quickly with a float parameter like this. Drag and connect that into the drag input, and feel free to experiment with that until you get the desired result. You can also further experiment with the initialized position. Right now we're spawning the particles from a moving cross-section of a torus. It's actually a little bit easier to see what's going on if we choose a different primitive as our source position. So let's just disable the torus block and create a position block for a sphere instead. Create block, position sphere, and let's have a look. This makes it a little more obvious what's going on. We can see the particles streaming off the surface of the sphere and attracting toward the target position. Now, if you think the torus looks better, you can just toggle this off and toggle the old block back on. At this point, our effect is making some nice progress. If you wanted to share it with somebody else, you might want to make some notations in your graph. If we select all these nodes, you can right-click, group selection, and let's label it attractive force. And that becomes a new node group, so you can drag all these around together at once. Now, if you wanted to add more detail, you could also right-click, create sticky note, increase the size of the font, and then you can just type up some notes to mark up your graph. You should be able to download the finished project from the GitHub link to see everything here. And now you should have enough toys to experiment with. So go ahead and try out different variations on our effects graph and see what cool stuff you can create. Okay, well that's all for this episode. Remember to check out the website for premium tutorials and the blog for our latest little game dev tips and tricks. Thanks everyone for watching. Until next video, you'll find me in the Game Academy.